Azure Data Factory, ADF, is one of the most misunderstood services in the Azure data stack. People treat it like a transformation engine, then wonder why their bills explode and their pipelines crawl. In the next 5 minutes, I'll give you the right mental model, what ADF actually does under the hood, the integration runtime that everyone glosses over, how the copy activity really moves data, when mapping data flows quietly spin up a Spark cluster, and the production gotchas that bite teams in month 2. Let's take it apart. Here's the core mental model. Azure Data Factory is primarily an orchestrator. Its job is to say what runs, in what order, on what schedule, and with what dependencies. By default, it does not transform data on its own compute. When you write a copy activity, ADF pushes the work down to the source and sync systems and a data movement service. When you write a mapping data flow, it delegates the actual transformation to a managed Apache Spark cluster. So think of a DF as the conductor coordinating other engines, not the band playing the music. That single distinction explains most of its cost and performance behavior. ADF is built from 4 nested concepts. At the base sit linked services, connection definitions and credentials to your stores and computes, like a connection string to a SQL database or a key to a storage account. On top of those, datasets describe the shape and location of the data, a specific table or a folder of files. Activities are the units of work, a copy, a stored procedure call, a data flow, and pipelines group activities into a runnable, schedulable unit with control flow. Get this hierarchy right and everything else clicks into place. Now the piece people skip, the integration runtime, IR. This is where the actual compute and data movement happen, and there are 3 flavors. The Azure Integration Runtime is fully managed and serverless, used for cloud-to-cloud copies and data flows. The self-hosted Integration Runtime is an agent you install on a virtual machine or on-premises box to reach private networks and on-prem sources. It makes outbound connections, so you usually don't open inbound firewall ports. And the Azure SSIS Integration Runtime is a managed cluster that lifts and shifts existing SQL Server Integration Services packages. Picking the wrong IR is the most common architecture mistake here. The copy activity is the workhorse, and its performance hinges on a couple of dials. Data Integration Units, DIUs, control how much compute the Azure IR throws at a copy. More units mean more parallel throughput, and you pay accordingly. Parallel copy splits the read into concurrent partitions. And staged copy routes data through blob storage as an interim hop, which you need for things like loading into Azure Synapse with Polybase or copying across networks that can't talk directly. Rule of thumb, let a DF auto-tune DIUs first, then measure before hand-tuning. Throughput is often capped by the source or sink, not by a DF. When you need real transformations, joins, aggregates, derived columns without writing code, you use mapping data flows. The thing to understand, each data flow runs on a managed Apache Spark cluster that a DF provisions for you. That cluster has a cold start, historically several minutes, unless you keep a warm time to live pool running. So a tiny transformation can sit idle waiting for Spark to spin up. The practical advice is to batch your transformations into fewer data flows, set a sensible time to live when running many in sequence. And for simple column mapping, prefer the copy activity, which never touches Spark. A few things consistently surprise teams. First, billing is per activity run plus compute hours plus data movement. So a pipeline that fires thousands of tiny activities in a ForEach loop can cost more than the data is worth. Batch where you can. Second, the debug button runs in a separate context and does not use your triggers, so debug success does not prove your scheduled run works. Third, publish to the live service or to Git, but pipelines only run from the published version, not your unsaved canvas. And fourth, parameterize linked services and datasets early. Hard-coded environments make promoting from dev to production painful. Always check current Azure docs for pricing and cold start numbers, which change. So here's the shape of it. Azure Data Factory is an orchestrator that delegates compute. Linked services, datasets, activities, and pipelines are its building blocks. The integration runtime is the real engine, and choosing among Azure, self-hosted, and SSIS runtimes is your key decision. Copy moves data with tunable DIUs, while data flows quietly run on Spark with a cold start. Your one actionable takeaway: before you build anything, decide your integration runtime and parameterize for environments from day one. That single discipline prevents the rework and surprise builds that catch most teams. Check the current Azure docs for pricing specifics before you commit. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.